I want to show you how easy it is to really get yourself set up with these two technologies and really be able to dive right into be able to set messaging up in your solutions. Okay, so yeah, a little bit about me. I've been doing software development using Microsoft for over 20 years. I've basically used .NET since the inception of the original framework. And before that, I used Classic ASP and Visual Basic 6. So I've been doing these things for quite a while. For the past 5 years, I've been specifically focused on developing for software that works with the Azure cloud platform and all that entails. So authenticating through Azure, incorporating all of the various services and consuming the various services like storage accounts, cognitive services, service bus, etc. I have a number of certifications in Microsoft Azure, as well as being a Microsoft certified solutions developer. And you can see my LinkedIn profile is also included right there for you. All right, so today I'm going to start by giving a quick overview of what Azure Functions are, so that if you're not aware of what those are, as well as a quick overview of the service bus, and then I'm going to talk about sort of tying them together, why you want to do this, and why this solution might make sense for you, as well as specifically how to do it. Then my favorite part, we're going to get into the demo. I'm a developer, so I love the code part. So I'm going to show you a little bit of the code and how easy it is to get started with these things. And then at the end, there's a question section in the webinar. You can just type in your questions, and at the end I'll save some time and see if I can answer some questions for you. So let's go ahead and get started here. Alrighty, so for those of you who might have seen my colleague Nick Altoff's presentation and overview of Azure Integration Services back in January, a couple of these slides might look familiar to you. He was nice enough to let me use a couple of the slides from his presentation. If you didn't see it, it's available on the 3Cloud YouTube channel, and it's a great primer into various integration services available in Azure. So Azure Functions, it's a serverless, event-driven, fully managed compute platform. There's when we talk about serverless for things like Azure Functions, there's a server somewhere, but it's not a server that you have to manage. It's sort of all handled by Microsoft and by the people who manage the Azure cloud platform. And your main responsibility is just the configuration of the service itself, as well as the code that goes on that runs the service. So flexible pricing models to fit your specific need. This is one of the nice things with Azure Functions. So the main one is the consumption plan. So with the consumption plan, you're only paying for exactly what you need. So it makes it a very cost-effective solution to only pay while the actual service itself is running. Although there are a couple of drawbacks to using the consumption, some limitations to it, such as if you need things like advanced network isolation, you want to isolate it within a VNet, or your service is always running on Azure. It's nearly constantly running. You might want to look at premium or dedicated, because if it's always running, consumption might not make as much sense, because that you pay while it's running. Whereas with premium and dedicated, those plans are a little bit that you pay a monthly fee for those, and then you get to use them. So function apps are custom code that are deployed into Azure and executed via triggers. So there are three main sort of I/O components to an Azure function. So you have your triggers, which are the things that sort of tell Azure, I want to run this function now. So it's some event that happens. So you have, you can either do it by a timer, HTTP webhooks, Azure Service Bus, which is the main one we're going to be talking about today, Azure storage events, Cosmos DB. There are so many triggers that can fire off a function app call, and they seem to that Microsoft keeps adding a bunch to that as they go. The second method for I/O in an Azure function app is an input binding. So an input binding, it's not super relevant to what we're going to be talking about today, but that is something other than a trigger that allows you to import information into your function app. So for example, if you had a particular timer call that you also wanted to have a blob be brought in automatically from Azure storage, you could do that with an input binding. Like I said, just so you know what that is, but we're not going to be talking too much about that one today. Then the third I/O message is for output. So an Azure function you can set an output binding, and then the Azure function will automatically sort of take your return value and apply that. So I'm going to be showing you an output binding that allows you to automatically have the Azure function write a message to an Azure Service Bus queue today. The languages supported, it supports a number of languages for writing Azure functions, which the nice thing about that is that you can write your Azure functions in whatever language is most comfortable to you. So there's C#, which is, I'm a .NET developer, so that's the one you're going to see the examples today. But most everything I'm going to show you today can be done. Most everything that you're going to see can be done in the other languages using the syntax specific to that language. There's also JavaScript, F#, Java, PowerShell, Python, and TypeScript that you can use. All right. So when you're developing Azure functions, so there's a couple of different ways you can develop an Azure functions. You can develop Azure functions. The first one is using Visual Studio 2017 and above, if you're coding in .NET specifically. I prefer to use Visual Studio 2019. I think the tooling for Azure functions is a bit more integrated, and it's a bit of a nicer development experience in Visual Studio 2019, but you can use 2017 for developing Azure functions. You can also use Visual Studio Code, or you can use the Azure portal. Now with the Azure portal, I typically only use that if I'm prototyping or trying to test something out. I don't use that one, the interface is built right into the Azure portal, because that writes your functions right to the actual function app. Whereas I think I like developing in the other two because it promotes more of a sort of a traditional software development lifecycle where you can develop the code locally, test it, maybe set up a pipeline in Azure DevOps to then deploy the code to the function app, and it sort of helps to enforce a traditional software development lifecycle there. All right, so when you're doing .NET development of Azure functions, in Functions version 3, there are two versions of .NET that are supported for Functions version 3. You can either do .NET Core 3.1 in process, or you can do .NET 5, which is called out of process or .NET isolated mode. Now, what that means is that so the function runtime itself runs in .NET Core 3.1. So in order to be able to run .NET 5, it will actually run your function app in a separate process to enable you to be able to develop your functions with .NET 5. So the service bus overview. So this is a highly reliable cloud messaging service that facilitates messages between applications and services. And I really like this for being able to do to create an application that has reliable messaging. I actually had a client project once a while back where we chose to use a service bus with function apps, and one of the nice things about why we chose it to do that was the receiver on the client end, they were increasing their capacity, but it sort of couldn't keep up with the amount of messages that we had to send through. So with using the service bus, I was able to be able to sort of throttle the messages back, send them, and make sure that they got there, so that that the receiver wasn't dropping all of the messages, and we were actually getting there. So that's one of the reasons why this is so nice for reliable cloud messaging and sort of making sure that your messages get where you intend them to go. So the various pricing tiers of this, when you're choosing this, the things that you sort of want to think about. So with the basic pricing tier, you're talking about paying, it's more of a pay-as-you-go type of thing, pay per number of messages, and it's really cost effective to get going on basic, but there are a lot of limitations to basic. So if you need to use so basic will only have queues, it will not have topics or subscriptions, which we'll talk about in a minute here, but basic will only have queues. So if you need things like topics or subscriptions, or you need some other advanced feature like automatic deduping of messages, there's a couple other things, you might want to step up to standard, which you start to pay a little bit more once you step up to standard. And then ultimately, if you really have high volume, you need multiple processors running, multiple message processors running, you need virtual network isolation, you need there's a number of other things, then you really want to step up to the more expensive premium if you need those features. So the two types of messaging entities within a service bus are first queues, which is first in, first out message delivery to one or more competing consumers. So each message is received and processed by only one consumer. So this allows you to scale out load balancing your consumers, where you can have multiple consumers pinging the queue for messages, listening to a queue for messages, but only the first one to read it gets, it's sort of first one in wins, and then once that message is successfully processed, then it can be removed from the queue, and then it's done. Then we have topics and subscriptions. This is more of a publish subscribe pattern. So this is useful if you want a particular message to go to multiple different consumers. So if you have many different applications, you can have it go to multiple different consumers. This is useful in a couple of ways. This is, if you have a large number of recipients, so you want it to go to more than one. Also, another nice thing about this is if you have multiple consumers that you need to read your message, you can, but say application A only needs to read every message is in the queue, or in the topic, I'm sorry, but application B only needs a certain subset of those messages. You can set up different filters on your subscriptions, so that one subscription can read all of them, one subscription can read only a certain subset of them. So it makes it useful for reading different types of messages and sending them to multiple consumers. Alrighty. So integrating Service Bus with Azure functions. So I'm going to explain a little bit about how these work. I'm going to explain to you the triggers and the output bindings. So this will explain the input and output of how to read from Azure function and then send to or read from a Service Bus queue and then send to a Service Bus queue. So triggers allow the Azure function to actually listen to messages. So this is what allows you to say, okay, I've got a message in my Service Bus queue, now I want to read it in. So this first example here that you can see, it's a very simple example. So we have our Service Bus trigger attribute on this property of this incoming queue message. So we have our Service Bus trigger with the first parameter is just the trigger name. Then you specify your connection string. I have a connection string Service Bus. So this is the name of your connection string in your settings, in your application settings. Then I have it as type queue message. This is a custom class that I created. So basically what Azure Functions will do is it will expect some form of a JSON message within the queue, and it will automatically try and deserialize that message for you. it will automatically try to deserialize that message for you into the queue message class. There are a number of different types that this can be. This could be just a string, which will just take whatever the string data from the message on the queue is and just read it in as a string. You can just do a byte array if you have a byte array on there, so you can you send a small file across it. You can, this queue message could be an array itself, and that would allow you to batch process multiple messages at one time. You could actually use, there's a messaging class that comes with the service job, or the service bus extensions, where the message class you could read in certain metadata about the message as well as the message information. And then it allows you to include iLogger implementation to log out information, to log out any information you want to within this function app. All right, the second example I'm going to show you here. This one it has all of the same parameters as the first one, but whenever you're talking about this one I added a couple of additional parameters that you can get the sort of metadata about the message. So you can get the delivery count. So a queue is able to deliver a message up to a certain number of delivery attempts. The default in Azure Service Bus for a queue is 10 delivery attempts. So if this Azure function fails, it can then try to deliver it again and see if it can get it delivered successfully. I also included the in-queued time, so whenever time the message was queued up on the Azure queue, and then the message ID. So this is the ID of the message on the Azure Service Bus queue. So it's the sort of the system ID of that message that Azure assigns to it. Alrighty, so output binding. So output bindings is what allows you to actually take a message and put it on a queue or topic for other consumers to process. There are actually a couple of ways to do this depending on your needs. The first one is the real simple. I want the return value of my Azure function to be placed on the actual queue itself. So in that way, you just add the attribute return, and then service bus, you specify the queue name. Again, the connection string name from your parameters, from your properties, and then the entity type. So I've used entity type.queue in this example. And then when you do this, you want the return type of your Azure function to be, like I have it set here, queue message, which is my custom class for a queue message. The second way we can do this here, so one of the things is, one of the common things that I will do is I will set up an HTTP function so that some other caller can send in an HTTP function, or can call my HTTP function, send me in information they want to queue up on the queue, and I want to return back a regular HTTP status code, 200 if it's successful, maybe 202 just to note that it's accepted, or an error code if it fails. So I want to return back an IAction result. So when you're doing this, when you have to return back multiple things here, you can also specify an output parameter of a queue message. So it's basically the exact same thing as the return attribute I showed above, but it's placed on the an output parameter of the method itself. So we have out queue message, queue message. So this allows me to return an IAction result and put a message on the service bus queue. Alrighty, so finally, and this one's sort of my favorite one. It probably has a little bit more overhead from a processing standpoint as it has to instantiate a collector object, but it's sort of the most powerful one in my opinion, and it can really do a lot. So so in my example here, so I want to return an iAction result to an HTTP, but at the same time, I want to run this method as async. So I want this function to run asynchronously. Well, you can't have output functions, you can't have output parameters in an asynchronous function. So what I've done here is I specified an iAsync collector as the class, which the iAsync specifies an iAsync collector of the queue message type, such that I will be able to add using the iAsync collector, and I won't have to worry about an output parameter. I can still return my iAction result back to the caller. The other thing about an iAsync collector, which is really nice, is you can add multiple messages to a service bus with one Azure function. So I've had an Azure function that needed to sort of process a CSV file, and it might need to send a message on the service bus for each record within the CSV file. So this allowed me to very simply loop through that file and just keep placing messages on the service bus. So these are the three main methods for outputting a parameter, and choose the one that works best for you. They all have pros and cons to using them. So finally, I wanted to talk about something that I've been following for a while now, is the WebJobs Extensions 5. So WebJobs extensions are is the library by Microsoft that ties service bus functionality into Azure functions. Or the WebJobs in general tie various things like storage, service bus, event grid. So they manage that actual interaction. And I wanted to talk about this because as I saw recently, it's currently in beta 6. I'm hoping this is released soon. It's got a couple of really nice features that I've been waiting for. The first one is, right now in your Azure functions, the best way to connect with them, to connect with service bus, storage accounts, things like that, are by using a connection string. Well, you have to take that connection string, place it in Key Vault so that it's secure, then read Key Vault from your Azure function, and then get at the various resources that way. Well, managed identity connections is something that's been around Azure for a while, and it basically allows a resource to say, okay, I allow this other Azure resource to access my information, and I grant that permission. And then on the back end, Azure manages that entire interaction. So you don't need to have sort of any human intervention. No one needs to know the connection credentials to get from one to the other. It's very secure, and it allows for the enhanced connections. The second thing is it's support. So currently with a service bus, you can have multiple delivery attempts. So the service bus will, the Azure function will read from the service bus, and then it will say, okay, so I need to read this message, then it'll read it, and if it errors out, the service bus will deliver it again. Well, Azure Functions is also going to include exponential backoff and retry. What could be nice about this is that whenever you're talking about the service bus delivery, it delivers it one right after the other, whereas this one allows you to specify a delay factor such that maybe on whenever on retry 1 to take 30 seconds, then 60 seconds, and so forth, and then that way, so that whenever you're handling transient errors, it gives it a little bit of time, so it's not sort of trying one right after the other. So that's what really makes that really make some of the retries nice in the future. Alrighty, so now the demo. So this is my favorite part, as I said before. I want to get into the demo here. Okay, so the first thing I'm going to do here is I'm already here in my Azure. I'm going to come in here. I'm going to create a new resource group. I'm just going to call this webinar, and then I'm going to create it. go into the webinar resource group, and I'm going to create, I'm going to type in service bus. Come up here. And I'm going to choose service bus. Subscription and resource group is already filled out. I'm going to type in the name here. Now, because this does create an FQDN with a fully qualified domain name with .servicebus.windows.net, this does need to be globally unique. So I check it, I get the green check mark. This is a valid name. So I'm going to leave the location, just East US 2, and then the pricing tier. And here are your 3 pricing tiers, as I said before: basic, standard, and premium. So we don't need any of the extra features today, and we're only going to be using queues in this demo. So I'm going to go ahead and choose basic. I'm going to choose review and create. The validation succeeded, so I'm going to go ahead and create. Now this is going to take a minute or so to create. So while this is created, I'm going to go in and start getting my code project set up. So I'm going to open Visual Studio. I'm going to go to create a new project. And we can see here in my recent project template, since I create a lot of Azure functions right here. If it weren't right here, I could come up here and search for functions. And there I have Azure functions. Click on next. I'm going to call this webinar demo. Click on create. I can choose my version of, if I want to choose a .NET 5 isolated, or I'm just going to leave this with .NET Core 3. I'm going to create an empty Azure function project with no triggers as of yet, because I want to show you setting those up individually. But you could choose, there's a number of different triggers. As I said before, there are many triggers you can choose from. But I'm going to not create one just yet. The storage account, so Azure function apps use a storage account to store some of its metadata and some of its secure, just basically it's basic secure processing information. But for local development, I'm just going to leave this with storage emulator, so I don't need to worry about a storage account. And I'm going to go ahead and hit create. It's going to create my project here. So I have my project created. Now, the first thing I'm going to do, since I'm going to be working with Service Bus, I'm going to go ahead and go here and go manage NuGet packages. And I'm going to go here and browse. And what I'm looking for here is I'm going to be looking for Microsoft.Azure.webjobs.extensions.servicebus. So this was the SDK I was telling you about that 5.0 will hopefully be out soon. Right now we have, it's still on version 4, so I'm going to go ahead and choose the latest stable 4.3 there. So this contains a lot of the interactions with the service bus. So I'm going to go ahead and hit install. And close out of here. So now I have my project set up. So the first thing I want to do before I actually create my function, so I'm going to go ahead and connect my code to the service bus using the connection string like I talked to you about before. So I'm going to come back into here. My resource is created, so I'm going to go to my resource. So here I'm in my webinar-demo. It's called a service bus namespace. First thing I'm going to do is I'm going to come here to queues. I'm going to add a new queue. So this will be the queue that we use in our function app to send information between the various functions. So I'm just going to call this processing. We have a max queue size in a basic service bus. You can go up to 5 gigabytes. I think premium, I believe, goes larger than that. But we don't. This is the total size of all messages in the queue. We don't need to worry about that. So we're going to leave this at 1 gigabyte. Max delivery count, this is what I was telling you earlier. If a message fails, this allows you this allows the service bus to try to keep redelivering it, and so it'll try this 10 times by default. You could change this delivery count. The time to live, so if a message is placed in the queue and nothing is actively trying to read that, it'll stay on the queue for a certain number of time. That's called the time to live until it expires. So the default is 14 days. Once that expires, they'll either remove the message from the queue, or we can choose here to just dead letter that message. Dead lettering a message, after the max delivery count hits 10 or it expires, what that does is it places it into a sort of a special sub queue under the processing queue called the dead letter queue. And then that indicates so that somebody can be alerted to the fact that, oh, this message couldn't be delivered at all. So somebody might need to take action on this. Enable partitioning. This allows multiple message brokers and message stores to process the various messages to help increase your throughput and what have you. We don't need to worry about that, so I'm just going to leave that unchecked for this. So I'm going to go ahead and hit create. Your queue is successfully created. Okay, so now we have our processing queue set up. So now we're actually going to connect the code we have, the code project we have with the function app. So I'm going to go in here to shared access policies. And by default, when you create a service bus, it gives you a root managed shared access key, which contains the claims manage, send, and listen. For security reasons, I like to only give things access to exactly what they need. So I'm going to create my own access policy here called function app access. And if you really wanted to get really secure, you can actually create a access policy on each individual queue and create connection strings that way. I'm not going to go that deep for this, but that is available to you. So I'm going to just go ahead. We don't need the function app to be able to manage the queue. We just need it to be able to send messages, listen for messages. So I'm going to create this. All right, so now we have our shared access policy. So I'm going to click on this, and then it gives us a primary key and a secondary key, which corresponds to a primary connection string and a secondary connection string. So I'm going to go ahead and copy this primary connection string. This will tell the function app how to reach the service bus. Now, normally when you're actually doing this in Azure, you would want to store this connection string securely in a key vault, which then the function app could access. But for local development, you have this local.settings.json, which I'm just going to use for the purposes of this. So we have our properties here. I'm just going to add another property under value called service bus connection, and I'm going to paste that connection string in here. So, and here's my connection string, but this service bus will be deleted after this webinar, so it's not that big of a deal, because you normally wouldn't want anyone being able to see this service bus connection. So now we have our function app actually connected to the service bus. So we're going to go ahead and start creating our triggers. So the first thing I'm going to do is I'm going to go ahead and create a new Azure function, and I'm going to call this submit request. And I'm going to create this an HTTP trigger, because this is what I'm going to use to actually submit a message to the service bus. So you have authorization level. We don't need to worry about this for local development, but this is what type of API key will you need to access this in Azure. So it's you can either have required to have a specific function app key for that function. You can require it not to have any API key. It's sort of open web, or require an admin key to access it. We're just going to leave this at function. So I'm going to go ahead and click on add here. So we have our submit request. Now, one other thing, like I showed you in my examples earlier, I'm going to create a separate class here as well. And this will contain our actual message on the queue, because this will allow us to just use a JSON packet that's automatically serialized and deserialized for us. We don't even have to really think about that. So I'm going to go ahead and create this. It's going to contain two properties, a GUID, which is going to be the ID, and a property of string, which we're going to call this name. So this is a very basic message, but this will allow us to have a custom message that we place onto the service bus. So I'm going to come back in here. As luck would have it, here's the standard HTTP template that the Azure project in Visual Studio gives you. As luck would have it, it already takes in a name parameter, so I don't need to worry about any of that. That was very convenient. So I'm going to go ahead here and I'm going to put in my using statement to call in the service bus extent, the web jobs.service bus. So I'm going to go ahead and put in this using statement, and I'm going to add my output parameter here, service bus. I'm going to give it a name. Here's the queue name, what I call it, processing. Going to give it my connection string, service bus connection. Remember, it's what I called the actual connection parameter in my settings. And I'm going to go ahead and give this an entity type .queue. So we're going to send this on the queue. And I'm going to go ahead and since I want this to be an asynchronous function that also returns an HTTP, I'm going to go ahead and use my iasync collector here of queue message. I'm going to call this the service bus collector. There. Now we have our output binding for sending a message to the processing queue over the service bus. So here, after the initial collection of my property from the template, I'm going to go ahead and call the service bus collector asynchronously, service bus collector dot add async, and I'm going to pass it a new queue message. I'm going to give it an ID with it just a GUID.new GUID. And the name, I'm going to give the name parameter. I'm just going to give whatever the caller of this passes in. So I'm just going to leave this response message. This would allow us to configure, we can configure a message. This is going to send back an OK object result. I'm going to leave that as is for this example. Often I will send back a 202 accepted with like maybe you could send back a 202 accepted with a location for checking, especially since this is going to sort of all be offline processing. That's a pattern I'll use sometimes is I'll send back a 202 with a location where people can go, where the caller can then check on the status and it will report back on the status. So I'm going to go ahead and run this. And here come the function core tools that sort of mimic running a function app on your local machine. So we have one function app registered here called submit request, which is the one we just started. So I'm going to open up my browser here, and I'm going to go submit request, and I'm just going to do name equals Lauren. And pull this back up here so we can see. So we can see we got hello Lauren, the HTTP tree. So we got our response message back, and we can come in here and we can see, oh, okay, this did fire successfully. So if we go back into our queue, here, go to the Service Bus Explorer. So in Service Bus Explorer, in our Azure portal, we have three functions. We can send a test message ourselves here. We could receive a message, which is a destructive read. It will actually, if you use this one, it will read the message, show it to you, and remove it from the queue. Or we can do what we're going to do is peek, because we don't want to destroy the message from the queue. So we're just going to go ahead and peek this. We see we have one active message. We open it up here, and you can see, oh, there's my GUID, and there's my name. There's my name. So, and the content type is application JSON. So you can see we successfully placed a message on the service bus queue. Alrighty, so now the next thing we want to do is we want to be able to read that message off the queue. So I'm going to come back in here. I'm going to stop this. I'm going to stop my core tools from running, and I'm going to I'm going to add another Azure function. I'm going to call this process request. So I'm going to create a service bus queue trigger. Again, as I said before, there are a number of triggers, but we're going to use service bus queue trigger. I'm going to put in the name of my connection string. And my queue name here is going to be processing. And I'm going to go ahead and hit add. So this will create us a function that we already has all of our stuff filled out here. It already gives us the service bus trigger, the queue name, the connection. We're just about ready to go. The only thing I'm going to change is their template makes it a string. So I'm going to go ahead and make this my queue message type, so I can read in my queue message. Again, if you wanted this to batch process message, you could just make this an array, and you can batch process messages that way. So I'm going to go ahead and into here, and I'm going to go log. I'm going to do a log warning, because in the console, the reason I'm doing a warning is that'll show up a little bit nicer for you. So I'm going to go ahead and do my queue item.id. I'm going to do log warning, name equals my queue item.name. All right, so now we already have a message in the queue that we've already submitted, so we're going to go ahead and run this now and see what this does. Starts up our core tools. Now we have two functions registered here. We have our submit request and our process request. And here's the output. We can see that it successfully read our message. We were able to access the properties of the message very easily. So now we're reading from a service bus queue. So that all processed successfully. Now the one last thing I want to show you here is I talked about the dead letter queue a little bit earlier. So if a message can't be processed, if it keeps erroring and you can't process a message, you might want to alert somebody. You might want to send an alert to someone. You might want to place you might want to log that in Application Insights as a fatal error on your message. You may want to do something with that so that someone knows this message tried to process as many times as the service bus would send it to us, and it just couldn't. So somebody needs to do something. So that's very easy to add that in here. So I'm just going to go ahead and copy this function definition here. I'm going to add another. I'm going to just add it right to the same file. I'm going to call this function process request DLQ. I'm going to call this run.dlq so there's not a naming conflict. And I'm going to add dead letter. I'm going to add the sub queue for the dead letter queue, which is $ dead letter queue. It's the queue name / $ dead letter queue. Now up here, I'm going to go ahead and access one of my metadata properties to illustrate to you the delivery count. So I'm going to go ahead and access that property. I'm going to do another log.log warning. Delivery count equals delivery count. We'll log that out now. And I'm just going to throw a new exception here so that every time this gets read in, the system thinks that this blew up and the service bus doesn't believe this message was delivered successfully. So we're just going to go ahead and throw a new exception here. A message has occurred. So every time this is called now, this will throw an exception. And then in here, we're just going to do log.log. We'll go ahead and log.log error. A fatal exception occurred trying to deliver message with ID. And then we'll do my queue item.id. So we'll grab the ID from that message and just log. Like I said, you could have this notify somebody. You could have this put it in Application Insight. You could do something else with it. But for this, we're just going to go ahead and say, you know, a fatal exception occurred. We're just going to log this out to the console window. So now I'm going to go ahead and run this again. Our core tools pop up again here. And we have our submit request, our process request, and now we have a new trigger registered called the process request DLQ, so for our dead letter queue. So I'm going to come back here, and I'm going to go back to this call, and I'm going to call and do error. We'll call this, let's do name error, or error Lorne. So I'll go ahead and submit this. And now, because we're in debug mode, so those developers out there, you know, Visual Studio will stop on an exception each time. So I'm just going to go ahead and continue through these. You can continue through. So you can see it's trying to deliver it multiple times. We keep coming back to this. So I'm going to go ahead and do that. So now if I come back here to the core tools, we can see, okay, see there's all of our delivery. We have our various delivery counts. You can see it tried to deliver it 10 times, but it just couldn't deliver it. And then if you come down here, you can see our dead letter queue fired, and our message logged out a fatal exception occurred trying to deliver the message, and there's our message ID. So all in the span of about 20 minutes here or so, 25 minutes, we created a service bus. We started up a functions project in Visual Studio. We created an HTTP trigger to send a message to the service bus queue. We created a function that would receive that message from the queue, and we handled fatal exceptions to the message where it just could not be delivered, so that it can be logged somewhere or some other action can be taken on it. So as I said, very easy, very quick to get started, and you know, very nice and easy to get started with messaging within Azure. So that was the conclusion of the demo here. So now I don't see any questions here. Let me see if there's any questions. Okay, I see one question here. Let me see what it is. Let's see here. Could we have a look at queue editing? A queue. I'm not sure what you mean by queue editing or queue editing. See here. Could you specify what you mean by that? Oh, the lettering. Are you talking about the dead lettering? Okay. Did I not explain what you were looking for here? Were you looking to see it in the portal, or let me see here. In the portal. Okay, gotcha. Thank you. Okay, so the dead lettered message. So I'm going to go ahead and I'm going to remove this here real quick, just so that it goes in the dead letter queue without being read out. So I'm going to go ahead and run this again real quick to show this. So I removed our dead letter processor. That way it still continues to error out. And I'm going to go ahead and submit this again. All right, and then I'm just going to continue through everything. Alrighty, so now I'm going to come back in here into the portal. So we're back on our queue in the Service Bus Explorer. So if you want to see what's in your dead letter queue, so I'm going to go ahead and refresh this. So you can see we now have 0 messages inactive and 1 message is in dead lettered. So what we want to do here is we can go in here and we can say, oh, okay, I want to get out the I want to peek at the messages in dead letter. So we're going to go here And we can see here that, you have a couple additional properties on a dead letter message. So you can see here, message cannot be consumed after 10 delivery attempts. The reason, max delivery count exceeded, and your other properties in here, you can see the delivery count is 11, and all of the other things. So that's pretty much what, how it looks in the portal. If you need to look at dead letter messages within the portal. I hope that answered your question. All righty. Are there any other questions here? All righty. If there are no other questions, then that concludes my my presentation. And thank you all for attending. And I hope you learned something today. So thank you.
All right, thanks, Lauren. I greatly appreciate it. Like I said before, you guys will receive a recording tomorrow around noon Eastern Standard Time. Thank you, everyone, for attending. We host webinars every Tuesday. The next one will be on October 5th. Please feel free to check out our social channels where we list these webinars, we list other company updates. Thank you guys so much for joining, and I hope you guys have a good rest of your Tuesday. All right, bye-bye.